Hello, everyone. Joe, it is a pleasure to be with you tonight and to introduce myself as Joe and not Gio, which is how you would read my name, in an English-speaking country, because most people that I work with just read my name and so always end up calling me Gio, and I sort of gave up trying to explain that, it's Joe, which is short for Giovanni. But here I am always among friends, and so you all know me very well, and you call me Joe, which is appreciated and refreshing. Anyway, Matt has done a very kind introduction. Thank you, Matt. Yep, I have written a book, and actually I just checked randomly today, and it is already available for purchase. The publisher didn't tell me that. It's a surprise, so I didn't have time to update the website accordingly. But yeah, the book is out, and if you'd like the starter to talk about tonight, maybe consider checking it out. The book is about test-driven development in Swift, and the thing that makes it unique is, as far as I know, the only one available right now that talks about SwiftUI and Combine. And I think that's pretty interesting. Yeah, I kind of shot myself in the foot there because I had a lot of stuff ready for UIKit, and then I went off with SwiftUI, and I had to research and learn a bunch of new things. But that's very fun. So, yep. Test-driven development suite, a practical introduction. I won't try to summarize the book in a talk or give examples from the book. I want to take a different approach and just look at a simple example that I won't be talking about any theory. We'll just start writing code. All right, let me just switch back to from Chrome to Xcode. Here we go. So here we have our a slightly more advanced version of the Hello World app that Xcode generates for us, in which if we pass the content view username is going to say hello username, otherwise is just going to say hello world. And one thing about testing, a common hurdle for people to start writing tests is that it is hard to write tests for existing code, and sometimes it can almost feel like you are wasting time because, well, this code has already been written, already works, so why should I spend my time writing tests for it? And I say, yeah, all right. If you are not sure where to start, just wait until you need to write some new code or until you need to make a change to existing code, because even the hardest code that is not written with testability in mind, you can always implement that change in isolation, test it very well, and then integrate it. And so this is what we're going to be doing tonight. We are in Australia here. We don't say hello world, we say good day mate. And so we're going to try and change this greetings app to say good day mate or good day whatever user it's being provided to it. So before starting with that, I want to get your attention to something, which is that to verify this behavior, because we're using SwiftUI, and SwiftUI is notoriously hard to write unit tests for, here we are just relying on the preview. So there are two preview windows because the behavior has twofold, if there's a user and if there isn't. And we need to use our eyes. We need to look at the screen and maybe zoom in and zoom out to check the code and add as many combination of the inputs as we need to make sure that they're all displayed properly. And the problem with our eyes is that our biological hardware is not as fast and reliable as the one of the computer. So testing code just manually like this is not the most effective way to go about it. So you want to change and have this good day mate, and we want to do it using the using test-driven development. What does this even mean? Well, test-driven development is about starting with a test. So the first thing that we're going to do is going to be add a test. Okay, so here we have I created a new XCTest case file, and I'm starting with a test list. The test list is an enumeration of all the different test cases that you think you might need to properly test the behavior of the code that you're writing. And writing the test list itself, instead of just jumping into writing one test, is a great idea, because it forces you to come to terms with all the different options, all the different things that your code needs to do, and you have this time to face the dragon and try to understand deeply what you're trying to build. Now, this test list is simple because our example is simple, but still there's two choices. So which one do we start with? Well, I like to start with the one that I can get done the fastest, with the one that seems the simplest to me. And in this case, it would be the one where there's no user, because I can just say, hey, good day, mate, without doing any string interpolation. So let's write the test. Here it is. Did you see how fast I can type? So what is a test? An automated test, a unit test that we can write in Xcode. It is nothing more than just code that calls other code. In this case, we write some code that calls this new function that is going to encapsulate all our behavior, and then we check what it does. Now, to get started, you can just write the function signature. I think your function should look like, and just do the simplest thing that makes the code compile. You could even do like a fatal error here to silence the compiler if you don't know what to put, but then your test would fail. So I just try to return, in this case, is a string, so just an empty string. A tip to organize your test is to follow the arrange, act, assert structure. So the first phase is the arrange phase, in which you can prepare the input or inputs for your system under test. The second one is the act phase, in which you produce the output that you're then gonna check. And so you act on the system under test, in this case this function, to generate the output. And finally, there is the assert phase, in which you check that the output matches what you're expecting it to be. If we run this test, what's going to happen? Well, this is something useful to do. Before running your test, you should sort of like have this conversation with yourself, check, hey, what do I expect the test to do? This way, if the test don't do what you expect them to do, you can take a step back and try to understand why your mental representation of the software didn't match reality. Did you make a mistake in writing the test? Did you make a mistake in writing the implementation? Who knows? But it's good to have this mental check. So I expect this test to fail because I just coded an empty string as the return value. We can run the test with the Command U keyboard shortcut and wait for Xcode to build for us. And run the test. This is taking a very long time. Of course, this is, so I've done a few live coding talks, and there's always something that goes wrong at some point. Oh, here it is. So I learned not to try and type the code because I always forget how to type, but apparently I need to find a way to run the test without bypassing through the simulator. Anyway, the test failed, and how can we make it pass? Again, what is the simplest, the fastest thing that we can do to make it pass, where we can just return what the test expects in order to pass. And we can do it like this. So, yeah, the test wants GoodDayMate to pass, and we just return GoodDayMate from this function. Now, while the test runs, I'll tell you a bit more about this technique. This technique is called fake it, or fake it till you make it, and is a great way to get started when you don't know how to implement some code. You just return the value that is going to make the test pass, just to establish this green baseline. What just happened is that we went from the test not passing, the diamond in Xcode being red, which we can call the red state, to the green state. And in test-driven development is all a game of going between the different stages, in this case red to green, in the smallest step possible. Okay, so now we have two choices. One is we can work on this implementation to make it real, or we can move on to the next test. I like to move on to the next test because the next test is gonna force us to write the implementation anyway. But whichever works for you, you can choose. So in the next test, we'll check that if we pass a user, that value gets interpolated in the string. So if we say greetings with username Ada, we expect good day Ada to return. Now, as you can see, this test I wrote as a one-liner, and yeah, arrange act assert is a great way to structure your test, but sometimes especially if you are already a bit familiar with the code base and with testing, having them in a one-liner is concise enough that helps readability more than having it split in different lines. So yeah, I don't mind the one-liner approach, but again, I'm trying to show you the two different ways, and you pick the one that you prefer. Now again, if we run this test, what is going to happen? Well, I'm expecting it to fail because the function is returning an hard-coded value. And in fact, it did fail. So now I want to go, I'm back in the red state. I have a red test, and I want to go to the green state with the simplest code that I can write, the first code that comes to mind, the smallest step possible. And in this case is just a boring if let name, use the name, otherwise return this GoodDayMate value. Let's run the test. Do I expect them to pass? Yes. And they passed. Okay, this is good. We are back in the green state, and we can take a deep breath, pat on the back. Right now, the software is doing what it is supposed to be doing. So far we've been going back and forth between the red and the green state. There is an extra state that we can move ourselves into, and it's called the refactoring state. And this is really the beauty that I find of test-driven development, why I like working this way, because it allows me to move in these small steps and do one thing at a time. So right now, our only focus was making the test pass, which means making the code work, without worrying too much about how the code looks like. And now that we know that the code works, because we have the test that validates that for us, we can think about how the code looks like and remove any duplication, make it fit with the standards of our code base, play around with it. And we can do it with confidence because we have the test that we have already written and that we know that they validate the behavior to help us. So something that we can do is there's a bit of duplication that GoodDay is duplicated. The code is a bit dense. You just play around with it and change it, do something fancy, because optional is has this map method. So if the optional has a value, use it. Otherwise, fall back to mate. And look, let's make a mistake here on purpose to verify whether or not we did it properly. And the test failed because I made a mistake during my refactor. And now if I fix it, the test should pass. All right. So now we have this working implementation, and the next step is to integrate it back into the original code, this SwiftUI content view. Here we go. So a few things to notice. This is just the cache. Yeah. A few things to notice. Again, this is already showing us what I think is a drawback of relying too much on previews to implement your SwiftUI code, which is that previews are a bit clunky. Every time you do some big change to the view itself, Xcode stops regenerating it because the code is not compiling, and so it's just wasting time. So now one of our previews disappeared from here, but the screen is still showing it because it's been paused. So you kind of need to go there and click resume and wait for it to do its job. And something that I want to point out that is kind of written in that blob of text in the comments is now that all the logic is outside of SwiftUI, we don't really need to have those two previews to check the different behaviors of that greeting function, because we have the unit test that does it for us. And so the preview itself really becomes something that we can use only to focus on how the code, the view looks like. And this, my friends, is the big secret behind writing unit tests and using test-driven development with SwiftUI, which is, in a sense, to test the SwiftUI applications, don't test SwiftUI. Move all the logic away from the SwiftUI layer and test that instead. When we were back in the UI kit world, we were dealing with stateful objects. So we could instantiate them, inspect them, and call methods on them. But in SwiftUI, not only what we get out of that body property is the opaque view that if we look into it, we get this SwiftUI specific representation of what we've written, but the framework itself just works in a different way. In SwiftUI, views are a function of state, not a sequence of event. So if we play by the SwiftUI rules and provide the same state to a SwiftUI view, we can be confident that it is going to render in the same way because the function is the same. The framework guarantees this for us. And it took me a while to grok it, but this is I found it liberating. There's a lot of tests that I don't feel like I need to write anymore because I can trust that the SwiftUI framework will handle all that stuff for me. How am I doing at time? I'll just show you one other thing because we have a very good lineup tonight and I don't want to take too much time for the other speakers. So you might have noticed all right. Here we are back online. That was fun, and for once it wasn't my fault stopping, crashing some part of my gear or anything else. So Rob told me I might have lost a minute or so of what I was saying. I'll just go over that very quickly. SwiftUI is amazing, and if you play by the SwiftUI rules and write your code in such a way that the view is just a declaration. It takes some state, reads it, and renders it. You don't really need to worry about writing unit tests for the view itself, because all the logic that generates the data that the view shows is outside of it, and you can write unit tests for that. Then I just called attention to the fact that if we pass a username that is an empty string, my preview failed again, so let's start it again. We're gonna get back "good day!" exclamation mark, which doesn't make any sense. Is a bug, and test-driven development is pretty cool for bug fixing as well, because you can write a test that reproduces the condition in which the bug occurs, and have the expectation for the correct behavior, and the test is going to fail because there's a bug. Then the bug fixing is nothing more than just applying the same test-driven development workflow, red-green-refactor, to update your code in such a way that the test and all the other one pass. So what's the first step here? It is to write a test for this scenario. And here it is, test greetings with empty string says, "good day, mate." We pass an empty string and we expect to get back "good day, mate," but I know that right now the test is going to fail because there's this bug in the implementation, and it failed. So how do we fix the bug? Again, we are in the red state and we want to go to the green state. Write the first code that comes to mind to get there as fast as possible, and then we can worry about making the code good. All right. So now added a bit of a check to see if the string is empty, and if it's empty, fall back to that to mate, otherwise just the value. And if I've done my job correctly, this test is now going to pass. And yeah, it worked, so we can consider the bug fixed. We were in the red state, we went back to the green state, and now we can take a breather, pat on the back, maybe commit the bug fix, and then see, have we got time for some refactor? Can we make the code better? And yes, we can. That code before wasn't that readable, so we can extract the logic to decide whether to use mate or not into his own little private function, and this also removes the duplication. We wrote mate only once, so that if we want to change it to something else, like a matey or something, we change the code only once. That's test-driven development in a nutshell. We write the test first, so that the test can help us shape the implementation of the code, and we can get fast-paced feedback on the changes that we're making. In the book, I use the name partition problem and solve sequentially. So you take even whatever thing you want to do, you can decompose it in little pieces, little slices of behavior that you can write a unit test for. And start with one, the one that seems easier. And in that context as well, you partition the problem and solve sequentially. First, you try to write the test. Then you think about making the test pass with whatever code comes out. And once you have the test passing, you can, with confidence, rework your implementation and make it better, remove duplication, remove hard-coded values. If this sounds interesting, you should, check out my book, which, as I discovered by accident, is already available on Amazon and on the press website. If you buy it and you want to leave a review, that would be very much appreciated. If you have any comment, get in touch with me. You can find me at MokaGio on Twitter, MokaGio, or on I think I am just Gio, Gio on the Melbourne CocoaHeads Slack. And yeah, thank you for watching. I hope you enjoyed the performance. Back to you, Matt.